everybody, how are we doing? We should be broadcasting, we should have audio. I can't see the one audio stream, computer audio. Let me remove that off here because I don't think that's used anymore. Good to see you, Sarah. Good to see you, Cameron. Let me delete this. Can I delete it? Computer audio? Maybe I can delete it, maybe I can't. But I think you can hear me. There we go. You can hear me, I just don't like that I don't see the one thing. Where is that computer? I have too many sources. I fix things up. Good to see you here, Hannah. What questions do people want to do right now? You like walk over to the screen to see it. Can I not just delete that computer audio right there? Filters, copy. Oh man, where is it? Or is it just always on there? There's camera 1 audio. I don't want to delete that. Good to see Olivia. What questions do people have right now? Where is that audio? Or maybe I should just move this up a tiny bit and I'll be able to see it. Oh, there we go. That fixes the problem. I saw that you did the homework last office hours, but I still need help with question 1 and 2. Is that on question homework 3, questions 1 and 2? Is that homework 3 for Stat 201, questions 1 and 2? Which ones are those, Sarah? Let me know and we'll start that up. I just started some chapter 4 homework. Let me know which ones we want to do here. Yes, awesome. Well, which one should we do? Which one should we talk about? Chapter 3 is a lot over conditional and marginal distributions. My hair keeps doing like weird things. Just gonna do that. Conditional and marginal distributions. We could start with that and then branch into some other topics. We are live here each time at this time on Monday, Wednesday, Friday. Question 1 would be great. Okay, let's look at some question 1. Thank you for being here first, asking your question. Then we'll probably do some chapter 4, but we can always do some 320, some 474. So if you're in those classes, say hey, whatever you want to talk about. I'm signing into my Pearson as we're doing this. Question 1 will be great. Is the music at a good volume? Can you hear the music now? It should be playing in the background. Nice chill. I can hear it. And I can also now hear. Another one. Got my sound effects back and I can hear them. Worked on that a lot this morning and got it going, so we'll have some more fun with sound effects. There we go. I think everything's good to go. Chapter 3, homework. Okay, so we're gonna work this, and I want you to help me out with it. And let's talk about how to do this. Let me go grab the timestamps right here. And where's my timestamp thing? Here's my timestamp thing. We are currently at 6:33, Stat 201, Chapter 3, homework, question 1. Add life is reflection. Assignment number 1, question 5. Oh, 320. Emily, good to see you here. We'll do some 320 after little homework 4. We're going to add you as mods. Okay, let's go here and start a question, and then we'll do some 201, then some 320. Okay, so we got our first question on the screen right here. Good to see you here, William. And we're going to write down each of these questions. And so we have chapter 4 homework for 201 next. And then we have BS 320, assignment 1, and question 5D. Okay, so we got that second coming up. So I'll keep writing them down because then I don't forget them. And I don't have to ask, what did people say? Here we go with this first question. So you are given a what here, and then 5F. We'll put 5F right after that. What is this on the screen? 320 should also know this. What do you currently see on the screen here? What is the name of this graphic? This is review right here. If you're in 201 or 320, we should know the name of this graphic. I'm talking about this thing right here. What is that called? We need a name. Emma, good to see you here. We haven't thrown any MuBot points out, so let's throw those out. What is the name of that graphic on the screen right there? We need the name of it. Also, we got the pen working. Huge thanks to Dwight and everybody. Is this Word? Kind of looks like it. There we go. I got the pen working yesterday, thanks to Dwight and Josh. So now I can actually detach my pen. Please work, pen. Please work. It is working. And then I can circle things. I need what this thing is called right here. The pen had a problem earlier where it was losing connection, so it wouldn't keep it. But I need what this is called, and you know, kind of. A conditional, we'll throw Cameron some points right there. A conditional distribution is when you see something like this. That's conditional, given people have a poor opinion. You bet, Sarah, we got 2 questions coming up. Let me know which one you want to do. We got 2 questions coming up on that. Put it in the chat, we'll do it here soon. So this is, given someone has a poor opinion, what's the probability they're a president of a college? So what would be the mathematics on this? Try to figure this out. We're just practicing the material. So given someone has a poor opinion, what is the probability they are a college president? And it should be about it should be 8 or 9%. Data Analytics 3, we could do some Data Analytics 3. I think we've got just enough time for that. So Data Analytics 3, put that on the sheet right there. Find this out mathematically. See if you can find it out right here. Even if you've done the homework, this is practice. This is a conditional distribution. Conditional distribution. Because you're taking one variable and looking within it to look at the distribution of another. Conditional means you set a condition on one, given someone has a poor opinion. So conditional distribution. Given someone has a poor opinion, what is the probability they're a college president? So what is that mathematically? What is that mathematically? This is review for 320 and 201. Because 320 just did some coding, and we just started doing these things right here. Does anyone know? We got to throw out some more points. Take some guesses. Great job, Cameron, right there, figuring out the mathematics. 30 over 351 by taking the total right here. Now, these things on the margins are known as a what? If you were to add up all the numbers, these things in the margin, which that'd be 57, if you add up all the numbers over there, these things in the margin, which display one variable, we'll do 6b, are the marginal display. So there's the marginal display for you. Conditional display looks within one variable right there. So good stuff. Is this making sense? 320 should also know this. This is what we're covering in 320 also, and I've got 6b marked for 320. So when it comes to it, we also need to know the name of this graphic and the name of the other graphic. So we could draw something like this right here, where actually we should have about more college or more adults than college presidents. So it would look something like this. What are the names of these graphics? The whole thing is a contingency table, exactly. So a contingency table is a bivariate display of two categorical variables. So you have a categorical variable up here. I need to add more pens to this. So you have a categorical variable here for opinion and a categorical variable here for someone's status. And then a mosaic plot is also going to be a bivariate display where you see the colors on it. You're actually going to see some of that for 320. We could show some 320 stuff on that. But contingency table shows the numbers, and mosaic plot shows you a graphical visualization. Those are pretty much your two best displays to use. So remember, contingency tables and mosaic plots. Contingency table shows you the number. Mosaic plot shows you the actual the visualization of it. And I'm going to do one really quick right here. So this is kind of a lecture version. So, and this is going to bridge for 320. So if you're here for 320, this is going into 320 knowledge. So we're loading up R, and I'm going to show you some 320 knowledge on this. And this will help the 201, I think, also. So let's see right here. Okay. So watch this. Let's go right here, and we're going to do library reg class, because I installed reg class yesterday on this computer for the regression. Did I not? Maybe I didn't. Installed out packages reg class, because I don't have it installed. It looks like it wasn't auto-completing, so it wasn't installing. 201, if you're still here, this is a big learning thing right now, so please don't leave. We're learning how to go to the medical researcher. Yeah, we'll try to do that here real soon, Hannah, you bet. And so check this out. I am going to load up a data set from students from 2010. And we are going to look at the association between someone's handedness and their gender. And so with this, let's see what we get right here. Now, someone's handedness is a what variable? Think about what kind of variable handedness is. Just think about these questions. This is review right now. Think about what handedness is as I copy Hannah's question right here. I think we'll be doing that in a little. It's categorical. And then gender is also what? Gender is also what? Gender is also what? So handedness is categorical, and gender is categorical as well. That means we get a mosaic plot. Ignore the permutations below. That's more of a 320 concept. But you see the mosaic plot here. And notice the distribution of males, ambidextrous left and right in here is a conditional distribution. This is given someone is male, you'll notice a little bit more are ambidextrous and a little bit more are left-handed. But it's very similar. If you want to see the actual numbers, go and look at the what. If you want to see the actual numbers and counts, go and look at the what. Because you can see there's a little higher percent of males that are ambidextrous, because 11 out of the 313 males. I think we're going to be doing that here a little bit. Abigail, thank you, Abigail. 100 points, so many people here. Where can you go and look at the actual numbers? Because you have a mosaic plot, which is the visual, which I'm blocking now. But to look at the actual values in it, go and look at the what, which is over there on the bottom of the screen down there. Just repeating it so we know it actually says it over there if you look at it. Go and look at the what. What's that thing called? Mosaic plot is the graphical display. And then the other thing is called a what? This is just repetition, 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 because it's one variable blank on another. So you have a variable contingent on another. Great job, Cameron, right there. Good practice. So you have one variable contingent on another contingency table. And so with this, you can actually look at the displays right here, the marginal percentages, and also the conditional that males, 3.5% of them are ambidextrous. And you can figure out all this mathematics. And all this is done for you instantaneously with software. That's what's really great. If you know what you're doing and you know how to read these, then it makes sense. So this is what we use in 320 to do work like that. I just write one line of code and everything's done. So going back to the original question right here, let's look at what it says. It probably wants for us, it says, what percent of college presidents think that higher education is a poor value? So we need to go here, and we're going to do the next question coming up. Bring up the calculator. What percent of college presidents, so there was 1060 college presidents, poor is 30 out of the 1060, and that's a conditional distribution. So 2.8% right there. What percent of US adults think it's good or excellent? So we need to take good or excellent and combine that together. And it's for the US adults. So good was 749 plus 105, because that's good or excellent. Divide by the total of US adults, which is 2127. Over there at the top of the screen, you'll see that number. We're just adding these up as the numerator, and the bottom is the denominator, for about 40.2%. And what do we get next? About what percent of college presidents thinks it's a good or excellent value. And you notice college presidents have a little bit higher of an opinion. There's fewer of them, so this is going to be more of the total. So we're going to add up the 629 right here plus the 184. And we're going to divide that by the 1060 and get 76.7%. Now, does that look like there is an association? Talk to me about this association you see right here. So, yeah, thank you, Harris in the chat. What association do you see? Given someone is a college president, they are more likely to have a what, and you could just kind of generalize that. So think about the association I see in this data is that given someone's a college president, they'd be more likely to what? Given someone is a college president, they'd be more likely to what? Higher opinion, stronger opinion. So given someone is a college president, and that shows an association. So college presidents have a better opinion is what we saw. And always try to think of the answers before. This last one right here, not my favorite part of this question. But if we look at the numbers, is it reasonable to conclude about 4.94% of U.S. adults think higher education system is an excellent value? So 184 out of the total 2127 is, ooh, is that not right? Oh, I didn't do U.S. adults, haha. 105 out of the 2127, there we go. So that's 4.94%. And this is kind of a decent estimate, so we look for one that says it, because this is a sample and we're trying to figure out for all. As long as this is a representative sample, it should be good. The sample is representative of US adults, therefore exactly, we would never say exactly. The sample is representative of the US population of adults, so the true value may be close to this, but not exact because the sample is only an estimate. That sounds right to me. So words like exactly are things we don't like in statistics. Check out the other office hours that we did on the 11th when we covered these other questions, and then we're gonna do some chapter 4 right now. So let's head over to the main screen, go back. Okay, thank you so much right there. I hope that helps out. I think it was Sarah asked that one. Let's do some chapter 4. We got a full lineup of stuff. Chapter 4 coming right up. I'm doing the quiz now. Do you have a quiz question you're stuck on? Quiz question you're working on? The homework wasn't bad? Would you rather, you asked this one, Cameron, is there a quiz question you're on right now? You say, hey Brian, do this quiz question instead. This is your question, Cameron. So if you want, and I might even just start doing more online office hours. We need to pump up the numbers, get more people in here, and start doing more. The homework wasn't bad. I just started it. We'll do some of the homework, and then maybe we'll circle back and maybe do some of the quiz later. So I don't know yet. Might be able to do the homework pretty quickly. Sometimes it's pretty easy homework. Okay, here we go. It's 53. Gonna take the re-timestamp this really quick. Put a better timestamp on it. Sometimes I think I'll go back and redo the timestamps, and then I don't. There we go. Okay, so here we go. The first question is about load times, apparently. The research and initiative, some group right here, measures something, load times, for airlines for every month from 2002 through September 2019. Here are the histograms comparing. Now, if we have multiple histograms, you can't just compare distributions with one histogram. So what they're probably doing is they're probably, right here we can see it, stacking the histograms. Stacking the histograms. It does keep your highest score. Yep, your highest score will be maintained. It keeps the highest. Thank you, Cameron, right there, helping out. So we'd probably use stacked histograms. Take a look at, what you want to look at is right over here. Stacked histograms or side-by-side box plots is what we're using in chapter 4 because we have a categorical X and a quantitative Y. So let's go back over here and look at the question now and see what they have. Evan, good to see you here. You about saying hey? Here we are with some probably stacked histograms. Well, they're side by side. We could have stacked them on top, put the same horizontal and vertical axis. Hints for the test. So if we were to stack them, they'd want the same axis. They actually look kind of similar. They both go from 60 to 90. The one on the right, the International, has a little bit lower of a central part of the data. And this one's maybe a little more left skewed because this one's a little more symmetric. They're both left skewed though. Remember, left to the low, right to the high. And if we ever say that, we have to draw the Monster Man because he's gonna be really sad if we don't draw him. So once again, we have these distributions, and here we are. There we go, there's Monster Man there, and that is left skew. And there's the tail, and this one's a little less skewed. Monster Man! So just easy way to remember, left to the low, right to the high, and this is the negative sign, this is the positive side, this is the left of the graph, this is the right. It can be called negative skew. We call it left skew, but you can call it negative skew. Just different names, same thing. With that, we know which way they're skewed. We see a little more centrality of the data a little lower right there, kind of where the mode is at. Let's look what the question asks. Okay. Both distributions are unimodal and skewed left. The medians are very similar, kind of. The IQR shows the domestic load factors vary a bit more. I think that's going to be it because I said that the domestic was more spread out. So if you look at the IQR, the domestic right here, because IQR is a measure of spread, so the domestic is more spread out, and that's apparent right there. You can look at the number, but also I noticed that it was kind of more spread out, and the IQR would measure that. We should be right on that. That was a good question. I like that question. If you just kind of look at the data, then you're like, oh, they're unimodal, left skewed. Medians are probably kind of similar. Could have said the other one was a little lower, but the domestic was a little more spread out like butter right there. This is what I say to toast.
Another one.
I don't know what I'm doing today. Let's look at this box plot right here. So we got a box plot right here that has extreme outliers. We can see where we'll start with the 5-number summary, and let's point that out. So we're just going to grab this and talk about it here for a little bit. I don't like that snipping tool keeps storing them. I just want a new snip each time. I'll look at the settings of it later. So here we are. The 5-number summary is if you were to take 4 quarters and put lines between them, you would have the min, the Q1, the Q2, the Q3, and the max. Usually the Q2 is called the median, but each of these is worth 25 cents, and with each of them worth 25 cents, this is after 1 quarter, 3 quarters, the lowest number, the highest number, and then we can think 0, 25, we'll put median right here, MED for median, and we can think about what percent of the data we are through. Now, another thing to note is that the IQR is just a distance right here between these numbers. So if we take the distance between Q3 and Q1, that is the IQR, just like the max to the min is the range. IQR. The R part of it means range. excuse me, meant to only underline the R. So the R is a range, that's a range. And then this part right here, I need more pens, is of the middle quarters, the interquarters. So it's the interquarter range. We can calculate those things from the data, so lots of fun to be had. The IQR, what is the IQR for this data? Nice and quick. IQR for this data is what? And then I'm going to ask an advanced question. You should be able to look at this and get the IQR like that. So I'm going to ask a harder question that could be on the test then. 5, William, getting everyone 50 points right there. It's 5. What we're doing right here is we're taking the distance between these numbers, and it's just Q3 minus Q1. The IQR is 5. Now, something we covered in chapter 4 that's maybe one of the hardest parts for people to remember is that the upper fences, which are not shown in these plots, are Q3 plus 1.5 IQRs. And this is just where the high outliers are in Q3 or Q1 minus 1.5 IQRs. So where are the upper and lower fences? Remember how you just said the IQR is 5? So you just said the IQR is 5, so where are the upper and lower fences? So that right there is 5. Where are the, nice job, Cameron, yes. Because what you get mathematically here is the Q3 is 25 plus 1.5 times 5. And Cameron put in the chat that that is 32.5. And then you'd have 20 minus 1.1 times 5. And that is equal to 12.5, I think, as long as I did the math correct. These are tougher questions. You'd have to first find the IQR. So the IQR is just the distance between these numbers right here. And then you have to plug in the Q3 value, the Q1 value, plug in the IQR. A lot of people get stuck on that. It's more of just a memorization thing, 1.5 because some statistician thought that was far enough away, and that is how we do it. Let's see what the question asks, because it might go into more detail. Who knows what it wants? Great job on those points. How will removing the electric cars affect the standard deviation? So that electric car is way over there on the right side of the curve. So outliers do what to standard deviation? I think they're far away from the data. Standard deviation is a measure of spread. Tiny Brian hype. Standard deviation is a measure of spread. Outliers are far away from the data. They're further away. So outliers would do what to standard deviation? Outliers are far away. They kind of skew it or they increase it. They would, does it say skew in the answer? It might say skew in the answer. I would say they inflate standard deviation because they spread the data out more because it's calculated in part from a distance from the mean because the standard deviation is a typical distance from the mean. Like on average, how do things deviate from the mean is standard deviation. So they're going to increase. Great job right there. Tons. We're throwing 100 points for all those answers people practicing. The standard deviation, if it is removed, look, we're saying removing it. So the standard deviation would be much lower. The only two answers are A and D, because if we remove it, it's going to lower it. Since the standard deviation is calculated by summing the data values, summing the squared differences. This is going to be it right here. Since the standard deviation is calculated by summing the squared differences between the values, the mean, removing the electric cars would drastically lower it. It's squared differences. That should be right. They're going a little mathematical on that. Now, IQR, remember, IQR is not impacted. That's why we use median and IQR. It is not impacted by outliers. So we should look for one that says what? Do you think it's A, B, C, or D? Could we go over some of the quiz tomorrow? We might, yeah, Emily. And swing by office hours anytime or post them on Discord. I post a lot of the videos I've done in the past. Emily, thank you so much for asking. I'll show you some points. And the IQR would not change. This is really good review right here. The IQR would not change. Nope, not much lower. It would not change because the IQR is not impacted by outliers. We'll try to, side-by-side box plots. Pretty easy. Let's do it. Side-by-side box plots. I don't know what I'm even saying. Side-by-side box plots in this question right here. And they want to know what's going on. Okay. So if you notice, we got the median at the middle of the box plots. And the median drops, goes up, up. Here in the summer months around, is that June, July, August? Yeah, June, July, August, I think, September. June, July, August are the highest box plots. We'll put that as a quote from Ubot here in a moment. So that might be it. Load factors are generally highest and least variable in the highest and least variables in the summer months. let's look at the variation. Yep, the min to the max is the range. Also, the IQR is a measure of range. Looks like there's more variation over here, bigger IQRs, slightly bigger ranges. So really, we're just looking at the medians, and we're wow. Man, you were right, Cameron. This is not bad. Yeah, Cameron said it's not bad at all. We're just like, we're going to get done here in about 10, 15 minutes. We love your accent. Oh, no, don't worry. I have fun with it, too. When I say, like, droit and blocks, that was just a misspeak right there. Don't worry, I have fun, Cameron. So I never thought anyone's making fun of me. I always thought people were having fun and laughing along. So which of the following statements are true about blocks plots? Blocks, no, the first one was on purpose. The second one is not. Box plots are great for comparing two or more groups. Are box plots great for comparing two or more groups? Yes or no? Are box plots great? Box plots, plural, not a box plot. Watch out. Yes. So visually we can see it right here. And let's grab the picture, and then we could look at this, and we have a box plot right there. But you can use side-by-side box plots to compare multiple groups. Absolutely good for comparing multiple groups. We're going to lose the answer that we got on that one. The center of a box plot is a box that shows the middle half of the data. So the box is actually the what right here. One of these boxes, side by side for multiple, yes, box plots, plural. Great job, Hannah, right there. Evan, good to see you, and Morgan, good to see you here. So this thing right here is a what? We're going to do some 320 right after this, after these few questions. That's the IQR, the interquartile range. So that is the middle half of the data. Box plots, plural, great for comparing. Middle half of the data. The center line signifies the median. 100% right here. The center line right here in all of these is the median. So you can compare the kind of 50th percentile of the data. Great job on those answers. And the last one, the values which are displayed by a dot or an asterisk are outliers, 100%. So an asterisk is something that is more than 3 IQRs away. Not everyone uses that, but these are, this would be -3, at least -3 IQRs below Q1. And then this right here is at least 1.5 IQRs below Q1 because it's a low outlier. Does that make sense conceptually to everyone? Like if there's an asterisk, it's like a super outlier. And if it's a dot, it's just a kind of an outlier. I mean, it is an outlier, but it's not as much as an asterisk. So we denote things being outliers if they're more than 1.5 IQRs below Q1 or 1.5 IQRs above Q3. And write that down on a note card. The notes have it, but it's one of those things you just got to memorize. Like 3 standard deviations is an outlier. We'll get back to it in chapter 5. Good question right there. Just some things we should know, and we should be able to recite those things. Last question looks to be a little bit bigger, but let's get it done. I got another group of people collecting data. When displaying data, does it need to be exact in order to be displayed, or can it be an estimate? Probably an estimate. Is that a specific question, Hannah? This data right here goes from, I think it's 2002 to 2019. And you can see there's an increase in the median, and then the distribution gets more tighter, which means there's less variation. The IQR is getting smaller, so it's less spread out. There's an outlier over here. So what do they say? Air travel immediately after extraordinary weather events was not typical. We really don't know that. Do you think the data for months affected by extraordinary weather events should be set aside in an overall analysis of load factors? Probably. Air travel immediately after extraordinary weather events was not typical of air travel in general. In order to analyze monthly patterns, it might be best to set these data aside. I'm not loving it. Yeah, I'm not liking it either, Cameron. 100 points. Air travel immediately after extraordinary weather was not typical. In order to analyze monthly patterns, it might be best. Is that what the other one said? It's probably not typical. It might be best to leave these days in the data. Yeah, that's just kind of a conceptual thing. I really don't like that question. I really don't like that question. I don't know. I don't know much to say. Side-by-side box plots on that one, comparing multiple distributions. It's more interesting if you look at like the yearly pattern right here with the decrease in the variation of the IQRs. It's probably like that one up there was something that happened, hence we should set it aside, analyze it, and there might be other things pulling the data aside. Whoever wrote this question, you did a bad job.
Wow.
Okay, we're going to do some 320 now. So let's go ahead to the main screen. 320 people. You in the chat still? How's the music sound? Should be good. Love the Owen Wilson. Wow, I know it too. Assuming you wouldn't put that something. Yeah, no. The exams are highly curated. Shout outs to Terry Higgins, Stat 1 coordinator making the exams. Terry! You might be able to hear me. Sean, good to see you here. Nayeli, good to see you here too. No, you can hang out. You still get points for being here. You get points for hanging out, being here. I'll try to connect some things to some 201. I'll give some hints for the 320 assignments here. Got to pull up the 320 assignment already. You're welcome. You're always welcome to stay. Going over to the assignment. Also, our exam question straightforward. The Canvas content is the #1 way. And 320s, you took 201. If you want to say anything, let's get some Big Brain 201 crew. Big Brain right here. Where can I find these videos? After they are posted, just 100%. You just join in and they're on. So they're here. They're just here. They had same link, same bat time, same bat channel. They are just right here. So all you do is click the link and it brings you right to the video. Okay. We'll have this assignment up. It's been pretty good. I had a Reese's Big Cup with Reese's peanut butter, and I got a donut. I've been eating just sugar this morning. I shouldn't do such a thing, but it's been pretty good. Pretty good morning. How's your morning been, Aaron? Let me throw some points. Just having a nice morning here. It's like, I don't know, I love teaching in person, but there's something special about like online, and huge thank you to Haslam with the studio setup I have, because it's really something that I can do this, like that they let me in. Yeah. Okay, where do I find homework is on computer? It's really hard to see. Do you know how to fix this? Oh, go to My Pearson. Go to My Pearson. Here, we'll go to the main screen now. Go to My Pearson. Dunkin' Donuts and Munchkins. I'm having trouble with the side-by-side box plots. Yeah, we could look at some side-by-side box plots coming up right here. I think we have time. We'll be doing that towards the end. Go to My Pearson to do your assignments. You can also increase font on your computer. If you can meet with me, we can take a look at that. Can I post screenshots on Discord? Sorry, I've never used it. Yeah, as long as you're not posting like major things on the assignment, try not to give things away. If you do, we'll just delete it and say don't post that. No one's ever gotten in trouble for posting things on Discord that they shouldn't. I have deleted 1 or 2 posts from students and said, don't post that. Like, that's too much. I've said, kind of gives away the answer. But yeah. And thank you, Jennifer, and everyone. Okay, let's take a look at question 5D. Now, what's really great about doing this is called an R Markdown file. And with an R Markdown file, what you have right here is you have just like questions. Yeah, of course, Emily. Emily, 100 points. Thank you for asking. Yes, please do that. Please do that. I'll probably take a look at it between classes if I have time, or between this and class. So in an R Markdown file, you can go to any question you want by clicking the table of contents. You can also click the outline, or not the outline, the visual to see what it looks like when you knit. And then you can actually edit things. I have to go here because I've just installed R on this computer, so hopefully it's good. But you can highlight and bold things like here, like you would in a Word editor. So if you want to make your document look a little nicer before knitting, you can go to the visual editor over here, and then you see your chunks with your code right here where you'll write your code. Do not write code out here in the Word portion, write it in the coding chunk portion. So I'm going to undo those changes, go back here to the source code, and then go down here to question 5. Because we're doing 5D. I'm going to try not to do the full question, but maybe I'll give away a little bit of hints here. A, B, C, D, 5D. Here we go. Okay. I'm going to run what's called all chunks above. Now, code chunks are where we put code. This is like a Microsoft Word part, or it's just kind of the free-form part of the document. You can just write whatever you want there and it won't crash it. There's things you could write that would crash it. Mostly you can't crash it. You could try and maybe succeed. But right here is where you'll really crash it if you just put something like Brian and then you try to knit the document. It'll crash because it can't find the object Brian to knit. So we're going to do this right here where we're going to run all chunks above. So I think it should run fine. Yep. So it's running every chunk above, and we've loaded in all this data now. So check to see if that works, if you're working on this. If it doesn't, message me, let me know. Now, it says we are working with, and which data set are we working with? We are working with the hit data set, the hit song data set. So down here, print to the screen the song names in rows 550, 551, 10,395, and 24,244. The phrase print to screen just means have it appear to the screen. So with this right here, this is a data frame we're working with. Let's go look at the data frame, and I want to ask you a question. Even if you're in 201, we're going to throw 100 points for this. What does this look like to you right now? What does this kind of look like to you right now? Kind of looks just like a what? What does it look like to you right now? What does that look like? Just think about what it looks like. I like that Emma right there. Kind of yeah, it's kind of like it's a bivariate display, right? Ooh, that's good, Emma right there. That's worth 100 points. Does it look like any program you've ever seen before? Does it look like a program you've ever seen before? Like if you opened up another program on your computer, does this whole thing right here look like another program you've ever seen on your computer? Excel, Nayeli, that's what I wanted to hear. Excel, right? Good to see you here, RotoWave and everybody. Got all the classics in the chat. So it kind of looks like Excel, right? Well, doesn't Excel have rows and columns? Excel has rows and columns, right? So think about this. 1, 2, 3, fourth row, right? You see danceability is fourth row. So that's the fourth column, column, what am I saying? That's the fourth column, because we're going over columns, right? Thank you so much, love the Cardinal shirt. Fourth column right here, and first row. Remember this value, 0.417. And now we go over here, this is not the answer, but we go right here and we put in hit, square bracket, row 1, column 4, and there's the value we just saw. Does that make sense that this is the value in the Excel spreadsheet in row 1, column 4? So we're in row 1, column 4. Just tell me the first few letters if I were to type 22. I don't want to hear the whole thing, or you could tell me if I were to do hit, square bracket, 2, 2, yeah, Sean, message me on Discord because I'll probably have to like join up, look at your screen, see what's going on. We get it fixed. We've been posting about that a lot on Discord. A lot of people have trouble starting. Message me, we'll get it fixed up. Message soon, we'll get it fixed. If I were to hit square bracket for positions, 2, 2, what would I get? You can just give me the start of what it would say. So look at the sheet right here. You're welcome, Sean. So hit square bracket, 2, 2, what would I get? You got it right there, the Serge right there, right? The Sergey Gainsbourg. So you would just go right here and go hit. How about this? Hit, and then let's do 1, 4, and I'm adding spaces. Tell me conceptually what this will do. I'll leave it at the bottom of the screen right here, but tell me conceptually what that will do. I want to hear conceptually what this will do. Conceptually what this will do, because this is going to answer a lot of the questions on this. Conceptually what this is going to do, it says hit rows, comma, columns. And rows is the vector 1 through 4. So conceptually, what will that do? This is the key to understanding it, being like, oh, hit positions inside of it, because that's what square brackets mean. Hit positions inside of it, 1 through 4, comma, 2. What will that do conceptually? So we're saying these rows and this column. So think conceptually. What will it do conceptually? Any ideas? Take a stab. We'll give some points for just guessing. Well, we're asking in the row space for 1 through 4. We're asking in the column space for 2. So what are we going to get? Can't exactly do it. I'm trying to do it, but we will get the artist 1 through 4, because the column 2 is artist, right? Not the 4 songs, but you will get, it's because it's artist, you'll get the 1st through 4th artist. Does that make sense? Do you see it on the screen right there, Nayeli? Does that make sense? Like artist 1, artist 2, artist 3, artist 4, because that's the 1 through 4 right here. And then the 2 means column 2. And then what you could also do is you could put artist and you get the same thing, or you could change it up to something like track, and then you could get tracks 1 through 4. Does that make sense right there? That we're now saying, give me rows 1 through 4, and then we can call the column name and say column name track. Another way to get the track is to do hit $track, and then this would be tracks 1 through 4, but track is now a univariate or one-dimensional thing, so we don't do a second comma. We just say give tracks 1 through 4, and there's the same code. How's this looking, Nayeli? Does this make sense on how to get information out of data frames? because now at this point, we just have to think, if we want, for this question, it says the song names, and the song names are going to be what? What's the name of the song name things called? Is it song name? Should be called song names or something, right? Artist. Is it not song name? The song names. Is it track? Is track the song name? I think it's track, right? Is it track? I think it is track. Okay, if I'm wrong about that, let me know. Yeah, it asked about that. So songs that you can see track and artist. Yeah, track and artist is track. Just double checking, because like, I mean, if you really want, you just go right here and do this. You don't have to do this, but you can make something called song right here. And now we have an extra variable created onto here called song. And now we could actually do it with song. But you have to create that to use it. So if we want certain songs, and I think people understand this, we could concatenate. I'm not going to quite show how to do it, but you could concatenate and take what? What is this right here? I'm walking right now, I feel like I'm listening to a podcast. Thank you so much, Emma. That's good to hear. That's funny. I like that. Some points for Emma right there. What are we seeing right here on the screen? So you have to concatenate if you want certain things. You have to do the concatenate, give me these certain things. So that says, go to hit the data frame, find the vector song inside of it, go to positions 2, 3, 10. So all we're looking at here are songs 2, 3, and 10. So that kind of answers that one right there. Does that make sense? I haven't quite done it. Don't write down everything I write down. Think about what I'm doing. Has anyone been able to do this one? Don't put the code into chat. But were you able to figure out this one? I really dropped some big hints. So Nayeli, I think, can do it. Evan's got it right there. We got that one done. Let's go look at some 5F. So the point is, if you know what to do with this now, you'd be like, okay, that makes sense. Okay. Using the levels function, let me quickly timestamp this. We've got time for a good bit more. Using the levels function, so 45, 53. Okay. Use the levels function, rename the possible values levels of the target column hit and flop to yes and no, then use tail to show the values of target in the last 10 rows of the data. So the levels function, I'm going to show a completely different data set. So this is data survey 10 right here. And think about this. Variables that have levels are what kind of variables? Like survey 10, and we have gender. Variables that have levels are what kind of variables? You could tell me how R sees them, but variables with levels are what kind of variables? Hey, Olivia, good to see your categorical factors. I was looking for categorical because 201, right? They're just categorical variables, and then levels are the answers to the questions. Does that make sense? Like, this is an easy variable to work with. So the levels of this variable are female, male. Does that make sense? The levels of this variable are female, male. Categorical variables have levels, and we go right here and we store into it. So now I'm going to overwrite the levels. I'm going to overwrite it with capital F, capital M. Does that make sense? Now, if I look at the data, see what I've done? Everything has been recoded. So we just recoded all the data. I could recode it again if I want, just by going here and doing female, male. And now everything's been recoded again. So we're just saying go to the levels and write into it the vector female, male. Now you probably want to look at it before you write to it to see the order of it and how it looks. Make sure to put it in quotes and you're writing a vector into it because it's right now a vector. So it's the vector female, male, and then you want to write into the vector whatever you want, which yours will tell you to write something different than what I'm doing. And so once you do this right here, you can do many, many things. You could simply go here and go to tail. Tail gets you the what of the vector. Q4F, I think we got enough time. Thank you, Alina, right there. Q4F gets you the what of a vector. The end values, yep. And then you can change this right here to head, and that's how many starting values you get. So take the start of survey 10 gender, give me the first 10 things. Take the start of survey gender, survey 10 gender, give me the first thing, and these are the last 10 in that vector. So you can look at it with the start of the end to see what's going on. Usually you don't want to preview a whole vector or else you get something like this on your screen. Watch out, you can lose points on your assignments or have them not graded if you turn in work like this. But Nayeli, I think if people are following along, I've pretty much done the work, right? So the point is like, you don't want to write down everything I'm writing down. I used a different data set, but you're like, okay, I see what he's doing. That's how he's renaming levels. That's how he's finding first or last things. That's how he's, so watch out. You won't write all of this. You have to think about, say about losing points. If you were to, let's say, and here I'll do this. I'll show this. You could lose points. I'm going to knit a document, and I'll show you how you would lose points. Okay. So I'm knitting a document here, and then I'll show you why you would lose points. Survey 10 not found. Sure, in survey 10. Did I use it in the wrong spot? 209. Oh, because I didn't do library rate cost, probably. Okay. Knit it again. 5G, yeah, we'll do some 5G here. People said 5G and what else? 5G and 4F. We'll try to do those right here. We'll barely enough time to do some data on X3. Might not have enough time. Okay, so here's where you would lose points. There. This. Does this look like what you turn into our class? Just pages and pages of printed data? Does that make sense? Pages and pages and pages and pages and pages of printed data. Look through your document, and if someone wouldn't read this and wouldn't look at this, don't turn it in or delete it. How do we fix that? If you have a Word document, what can you do with things? If you don't want it in here, you can go back and fix the code, but you could also do what in a Word document? What could you do in a Word document if you want to fix it? Because you wouldn't want to turn this in, like as is. You can just delete it. Yeah, so look at your Word document after knitting, make sure it has what you want. You can clean up your Word document, but a lot of people have turned in, like this right now is 78 pages. It kind of crashes the reader we use to look at things. So the speed grader. So delete things, look at your document. Some people have turned in, done a lot of hard work, and then we're like, we can't grade this. People have turned in like 4,000 pages. I'm not like joking. We get 4,000 pages turned in, and all these people saying delete. Sounds like it's a L right here, if you know the meme. So we have 6B next. So let's skip down to 6B and talk about the theory behind it. Okay, 6B. I was doing this one yesterday. Swing by office hours today. I have to leave a tiny bit early because I'm getting a crown on my tooth at 3:30 today. I say, when do you go to the dentist? At 2:30? 2:30? I'm going at 3:30. Create a column named return rate that returns a fraction. Yikes. Oh, it's fine. I got the temp on now. That returns a fraction between 0 and 1 of items returned last week. Hint, here's the formula. Print to the screen the following result. So right now, it's not displaying the formula until we kind of hover over it or click beside it. There's the formula. This is LaTeX, which is just a way to do fancy stuff within documents. It's not actual R coding at the current present time. Now, I'm not going to quite do this, but what is the formula for BMI? Does anyone know BMI formula? What is BMI formula? It's weight in kilograms divided by height squared. So if I were to take my Survey 10 data, and you notice we have height and weight. Now I'm going to pretend the height's in kilograms and the weight's in kilograms and the height is in meters. I could convert them and we'd just spend more time doing conversions. But with this right here, if I have this, I can go right here and go to Survey 10 and I can go to BM. Now why didn't it appear? Think why Survey 10 BMI is not appearing. It's because BMI right now is what? Why did BMI not appear? This is the theory behind this question. So if you're wondering why am I doing something different, why does Survey 10 BMI not appear? Think theoretically. And if you look at the names of the data frame, you can get hints for this. So the names are the names of the columns. If you look through that, what do you not see? So I type BMI, nothing's appearing. What's going on? What's happening? Survey 10 BMI, that's what I want to do. I want to figure out BMI. It's not there. Nayeli, great answers right there. It's not there. So what if I were to do this and watch Survey 10 right here? And I'm going to delete everything out of the global environment so we can just focus on Survey 10. So keep your eyes on. We're going to reload survey 10 real quick. So that way we can only look at survey 10. And I want you to notice this. It doesn't exist. Great job, Sean, right there. BMI doesn't exist, right? And now we'll zoom out a good bit, and I want you to watch this. I know it's a little small, but watch this. If I do this, what do you notice just happened? So look there at the bottom right of the screen, and what just happened when I said store into survey 10 where BMI exists inside of survey 10, because these are the vectors inside of it. Now what do you notice? By storing into something that doesn't exist, it added a new vector. Now, since I put 2, it put 2 for every value of BMI. But we don't want to do that. Great job, Jennifer, right there. It created the BMI vector. But we don't want to put 2 for every value, right? We want to do, and we're pretending we have the right formula right now. We want to do survey 10, $weight, love the autocomplete, divided by survey 10, $height squared. And now we've calculated the quote-unquote BMI for everybody. Does that make sense right there? That now, because I've written the formula right here, we're going to show it back on the screen here in a second, but I've written a formula where it does the calculation for me and stores to where that thing exists. That's not your formula, that's not the formula you're using, but you can write things where they don't exist, and then they will be created inside of a data frame. Like if I wanted to figure out tattoos -3 or something, yep. So if we go here and we go survey and we go total mods, and we have here survey 10, number of piercings, plus survey 10, tattoos, is it? Num tattoos. So now we have total modifications someone has, piercings and tattoos. I guess we didn't include subdermal implants, but that's the total number of tattoos and piercings people have, total modifications. So all I'm doing is just creating new vectors inside of there, and you can easily do that by just writing to a variable that doesn't exist, and the variable will get appended onto the data frame. Good work right there. These are tough questions, but I mean, if you see how to do them, it's like, okay. And it's kind of neat because like when you know how to do these things, I've done these things a lot. And so you kind of just like, oh, we just want to add a new vector. Oh, we just want to do this. Let's see right here. We got 5G and 4F. Oof. We'll try to do some more in class. I might try to do more of these office hours because they're starting to spin up a little bit. Okay, we got 5G right here. So let me take the timestamp and then we'll start 5G. Okay. 56. 23. Okay, here we go with 5G. Which row contains the most danceable song? So what are we looking for? The what danceability? The what danceability? So when you look at danceability, we can go here to hit, which we no longer have. I'm going to load all the data above. The highest danceability, right? What's another word for highest? What's another word for highest? The what? Greatest. What's a word that we were talking about in 201? It's part of the 5-number summary. We are looking for the what danceability. It's part of the 5-number summary. So this brings us back to 201. We're looking for the what danceability, the maximum danceability. Now, there's longer and there's quicker and easier ways to do things in R. Because let's go look at our survey 10 data. I have to write this because some people listen to this on mute and they just copy what I do and then they're like, I got it wrong. I printed a bunch of vectors. Like, don't copy exactly everything I do. Can we put that in the chat real quick so people can see it? Like, don't write down everything I'm doing. Don't just print vectors to the screen. Does that make sense? People turn in what I do because they just watch the video and they write everything I write. Like, you're not meant to copy it. You're meant to like see this and be like, oh, that's the danceability right there. But you're not meant to print the whole vector for this. Don't copy everything. Don't just sit and copy everything. Be like, oh, Brian's just looking at the danceability. Or we can make a summary of danceability, which is what we would probably do to look at the general values. And you know what we can see in the summary? In the summary, which this is not a bad idea, we can see the maximum. So don't copy everything I do. Look at what I'm doing and being like, oh, the maximum danceability is 0.988. But here's something I want you to see. We have here survey 10 data, and this person, let's go to this one. These two people are the what is people. Person 591, 428 are the wettest people. Person 591, 428 are the wettest people, tallest people. Gotta be some way to figure that out without going in and looking at the data, right? Well, a function that's amazing is the which max function, or which min. Which max tells you what? It tells you which one is the what. Think about what which max does. It's a function called which max. It tells you which one is the what, which I hope it returns 2 elements for this. Like, think theoretically, the function which max tells you which one is the, it's called which max. And watch, we put in here survey 10, $height. Ah, it only returned the 1. Come on, which max? Tells you which one is the max. 428, they are also the person who weighs the most. They're the tallest and they weigh the most. It should, I wonder if it has something in it, if there's 2 elements. You can look at the help file on it to see like if there's 2 elements, but it's a bummer. It should return, it tells you which one is the max, exactly. So Cameron right there, 100 points, following along, 201, love it. Just tells you which one is the max. So nice and easy. See if that helps out for that one. We'll do 4F right here. We got a little more time, so let's go check out 4F, because that one's, last one to do is pretty easy. Some of the elements of RP, which I don't think we have stored right here. I think we have to create this. There we go. Some of the elements of RP are equal to this, 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 and this. By using the percent in percent, percent I in percent shortcut, print to the screen all elements in RP that are equal to one of those values. Note some of these values do not appear in RP at all. So similar work by Brian again. Someone's gonna put like similar work by Brian. Okay, don't copy what I do. So right here, RP is going to be a vector. Save the response proportion. So we're gonna go here and lead it in. We're gonna go to, well, we need to have reg class going, data charity, there it is right there, and charity, $ that, there's the vector, and then we're gonna store it. So just to briefly mention what this code does, line 117 loads the charity data frame. Charity is inside of reg class. You can see that if you start typing charity, you get reg class beside it, so you need to have reg class on. So if you don't see it, reg class is not on or it's not installed. So this will load the charity data frame on the right, and then here we are storing into RP, making a vector, the response proportion. 4C, is that 4C? Might have enough time. Oh, I didn't mark this one right here. 2 seconds, let me mark this Nayeli. We'll do one more here, and then we'll need to do more 201 next class, or next office hours. Thank you, everyone, for being here. Trying to do as much as we can. So this is just loading it. Is that 4C? FC, is that 4C? And so this is for F right now, 4F. And so some of these elements do not appear, or do appear. And so the percent I in percent shortcut is a really good one right here to check multiple elements. Let's show how that kind of works right here by looking at this. Are there in-person 320 office hours tomorrow? Yes, 1 to 3. Oh, tomorrow I have a meeting. Oh, geez. I'll be sending an email about that one. I have an undergraduate meeting for our department. So tomorrow I won't have that. Maybe I can try to hold some after that. Let me try to do that. So I'll stay here a little bit after and do that. And then I got to record videos. Woo, woo, woo. We got this. We got this. Okay. So I want to show you something really cool right here. Understand what percent I in percent does. It means contained in. Are you ready? Here's how this is read. Is 4 contained in the vector 4, 10? Yes or no? I just want a yes or no. Is 4 contained in the vector 4, 10? Is 4 contained in the vector 4, 10? Is 4 contained in? Yes, it is. That's true. Is, now be careful here, we're going to mix it up a little bit. Is 2, 3 contained in the vector 3, 2? So the way this is read is 2 contained over there. So is 2 contained over there? Is 3 contained over here? Ah, good, Nayeli, good work right there. The answer to this one is yes, yes. So is 2 contained over there? Yeah, 2's contained over there. Is 3 contained over there? Yes, 3's contained over there. We're not looking at where it's contained. We're just asking, is 2 anywhere over here on the right? Does that make sense? So is 2 anywhere over there on the right? The order doesn't matter unless, and this is why I did this, unless we did logical equals. Now this will do a pairwise check where is 2 logically equal to 3, is 3 logically equal to 2? Like, is it equal? Logical equals means, I said logical equals for like equals equals, because equals is set something to it. So this will return false, false, because it's saying is 2 logically equal to 3? Is 3 logically equal to 2? The first one on line 158 reads, is 2 contained on the vector on the right? Is 3 contained on the vector on the right? So if you look at our question, it says some elements of RP are equal to this by using the %i% shortcut to screen all the elements in RP that are equal to one of the values. So you want to find all those values by using, what does it say? We need to print, by using the %i% shortcut, print to screen all elements in RP that are equal to one of these values. So I want you to print all the elements that are equal. So what we need to do, and let's do a similar example. I think I know exactly what we want right here. Where is it? So if we had a vector, let's say random numbers. Random numbers are going to be sample from 1 to 100, 1,000 numbers, replace equals true, and round these numbers. Here are 1,000 random numbers. Does that make sense? Yep, it's coding class. Yep. Oh, cool, Jennifer. You got some good help there in high school. So I just made 1,000 random numbers between 1 through 100. 1,000 random numbers. And with 1,000 random numbers on the screen, I want to print to the values. Good to see you, Drew. I want to print to the screen the values, let's say, of interest are going to be numbers 7 and 7, 12, 42, 60, 17, 14, 3. There we go. 7, 12, 42, 60, 17, 14, 3. Those are my numbers of interest. So now we go right here and we ask, I want to double check what Petrie wants on this. So are the values of interest contained in the random numbers? Ooh, what did I do? Oh, I did pipe, sorry. %, I did a pipe, different thing. Oh, no. Are the random numbers contained in the values of interest? So the random numbers are all these random numbers here. So it'll say, is 93 contained over here? Is 40 contained over here? And this vector is just this vector over here. Does that make sense? This is probably the hardest one we've done yet to understand conceptually. So the random numbers is too large for me to print on the screen, but it'll look and say, is 93 contained over here? Is 40 contained over here? Is 100 contained over here? Is 46 contained over here? So it's going to do that right there and run all of that. You could just use interest, or you could use the vector itself. And then there's all of those things right there. Now it says print the positions. I think it says print the positions. So print to the screen all the elements in RP that are equal to one of these values. It just says some of the elements of RT by using the percentage, print to the screen all the elements in RP that are equal to one of these values. Okay. So now we have the positions of them. So I'm going to store that here as positions. And there's the positions, or we can do a which, and it'll turn the trues to the positions. So now this will bring the first position back as position 15. There it is right there, because that's where the first true was at. And there's all the positions. And then with this right here, we're going to take, is there a Word document that shows how ours should look like? You can ask me if yours looks right. I mean, it should just look like answers and questions. And then here we want to go to the random numbers I have. And then we want to go to the positions inside the random numbers. And there you go. So notice how I've only printed the values that we want. And let me read what it says again to make sure we did it. It says print to the screen all elements in RP that are equal to one of these values. It says all the elements. So these are all the elements that are equal to one of those values in my random vector. I was interested in these certain values. This is a much harder question right here. So if you're stuck on this one, maybe swing by, we'll take a look at it. This is a tough one. with that, we'll be doing some more office hours coming up here. We'll do an outro video. Let's do the Thanos outro. Bye for now, everyone. 100 points coming in. Bye.
Hey, Brian, what's up?
Hey, Adam.
Oh, what's this?
Adam, what are you doing? Adam.
No!